Well, welcome back to a second night on solving rational equations. The twist tonight is these equations are going to have irrational and or complex solutions. Okay, so what do I mean by rational? Let's just kind of review that word. A rational solution is a fairly nice answer, something that can be expressed as a ratio. Perhaps we got x equals 4. That is rational because I can express it as 4 over 1. Maybe you got something like x equals 3 over 7. Again, that's a ratio. That's a rational solution. We're going to get tonight irrational solutions. Okay, and an irrational solution is probably going to have a radical in it. Maybe something like x equals 2 plus or minus radical 7. Okay, and then of course we're going to get some that are complex. And complex just means that we're dealing with an imaginary number. Maybe something like x equals 2 plus or minus 3i. Okay, we're going to deal with the imaginaries. Now, when you get an imaginary, they usually give you a pretty big hint and they say, express in simplest a plus bi form. They're kind of implying that you should get an imaginary number. So let's slow down and put in the rules or guidelines for solving these rational equations. Okay, so number 1, let's go ahead and bullet them or number them. We're going to factor any denominators. 2, we're going to state what makes the fraction undefined. 3, we'll state and identify that least common denominator. 4, we'll multiply each term by the least common denominator. We'll cross off the denominators and solve the numerators. And then the big bear, of course, to check and reject any answers that x cannot be. All right, so let's take a look at our first example. Solve for x to the nearest tenth. Notice that's italicized. They want it to stick out. Okay, if something's going to be solved to the nearest tenth, that means it's not probably going to factor nicely. So I would star that right away in your notebook and say, okay, this is the exam's way of hinting that I'm going to definitely need to use that quadratic formula. It's not going to factor nicely for the most part. It's going to be what I'm anticipating. So again, nearest tenth is a big hint. They're never going to say, hey Johnny, time to use quadratic formula. That is their hint, nearest tenth. All right, so let's first go through our steps. Let's identify whatever makes this fraction undefined. Now remember, this guy's not a fraction at the moment, so I'm going to put him over 1. So as I check, I have a monomial, 1 term, and a binomial, 2 terms. So this denominator, x cannot equal 0, and this denominator, x cannot equal negative 3. Okay, so my least common denominator is the monomial x and the binomial x plus 3. So I like to rewrite it. I like to keep things nice and neat. I'm going to go through and I'm going to multiply each term so they have the same common denominator. So again, this bear has an x. It needs to be multiplied by the x plus 3, top and bottom. Okay, this guy has the x plus 3. It's missing just the monomial x. So it's going to get x to the top and bottom. And this last fraction doesn't have either. So it needs the x and the x plus 3. To the top and bottom. Okay, so now as I glance, they both have the same common denominator. I can cross those off, and I'm just going to solve the numerator. All right, so this first term, 1 times x plus 3, doesn't get nicer than that. Anything times 1 is itself. 1 times x, another nice term. Now, this last one, maybe not as nice. Here's what I suggest. Take the first 2 terms and multiply them. So 3 times x, I'm going to circle them. What do they make together off to the side? 3x. Now cross them off. You took care of those 2. So now I have to do 3x times what's left, which is x plus 3. And I'm going to distribute that through and get 3x squared plus 9x. Okay, so we're going to set this equal to 0 because it's a quadratic. Let's see, so I really have 2x plus 3 over here. Equals 3x squared plus 9x. I'm going to set this equal to 0, so I'm going to subtract 2x, So that's 3x squared plus 7x. I'm also going to subtract 3, so minus 3. And again, I'm not going to waste my time trying to factor because I read the directions and it said nearest tenth, which is telling me use quadratic formula. Okay, so let's visit that again. X equals negative b plus or minus the square root. Parentheses are your friend. B squared minus 4 times a times c divided by 2a. You should be able to do in your head, so I'm going to say over 6. Okay, so I'm going to grab my friendly calculator. I'm not afraid to type all that in at once. Do not type the radical in, just the junk under the radical. And I get radical 85. Now I want to remind you, you have two answers, and I want you to split it up. You have x equals negative 7 plus radical 85 all over 6, and x equals negative 7 minus radical 85 all over 6. Now, don't waste your time. Remember, it didn't say simplest radical forms. Do not waste your time trying to simplify this radical. Just type it in the calculator because it said nearest tenth. So here's where we need to take a break. If you have the TI-84, the updated calculator, you have that alpha tool, that fraction tool. I believe it's alpha y equals. Grab it, press it. Okay, if you're not going through the motions here, you're only hurting yourself. Grab it, press it, and you're going to type this in exactly how you see it. And then you're going to type this in exactly how you see it, and you're going to write both your answers down to the nearest tenth. Now, my friends with the old TI-83, you do not have this nice feature. You have to be very, very careful how you type this in. So if you have the old 83, I'm talking to you right now, jot this down. Okay, your numerator has to be in parentheses, so you have to type in negative 7 plus radical 85, close the parenthesis, divided by the denominator in parentheses. Then you'll need to do the same with the other one. Negative 7 minus radical 85, numerator in parentheses, divided by the denominator in parentheses. And type that in. Hopefully you've typed it in yourself, and I get x equals, what did I add to the nearest tenth, 0.37, and x equals negative 2.7 for my two solutions. Now notice, do I have to reject either of those? Well, as I go back and check what made my fraction undefined, unless I got a 0 or negative 3, we're going to say those solutions hold true to this equation. All right, example 2. Solve for x and express your answer in simplest radical form. So again, they're telling you right in there that they want to see an answer in a radical. The only way for that to happen, we've been doing this for months now, is for you to use the quadratic formula. That has a radical in it. So like we said, they're not going to come out and say, all right, Sally, it's time to use that quadratic formula. You've got to catch the details. Nearest tenth, radical form, etc. So let's set it up the same way. I'm going to put this fraction over 1, and I'm going to say what x cannot be. In this fraction, x cannot equal 0. And in this fraction, x cannot equal negative 1. All right, so I need a monomial and a binomial least common denominator. So hopefully you're on the same page saying that you need a monomial of x and a binomial of x plus 1. So you know by now I like to keep mine neat. I'm going to rewrite this. And I'm going to use a different color to show my common denominator. So this first fraction has the x. It's missing the x plus 1. So top and bottom. The second fraction is missing the x. And this third guy, this lonely guy, is missing both the x and the x plus 1. Alright, so just like normal, we've got common denominators. We can eliminate the denominators once they're all the same and clean up the numerators. So if I distribute there, I get my 4x plus 4. Here I'm going to get my minus 3x. Okay, so remember, 3 terms. Some people get confused. Just take the first 2. So I'm going to do 7 times x, and I'm going to scratch it off and say, okay, that's really 7x. And now I'm going to multiply by the x plus 1. So I'm going to distribute and get 7x squared plus 7x. Okay, since I have a squared, I want to set this equation equal to 0. I'm going to put my like terms together here, so I really have 4 plus x equals 7x squared plus 7x. So I'm going to set this side equal to 0, so I've got 7x squared. I'm going to subtract this x over, so plus 6x. And I'm going to subtract that 4 over, so minus 4. All right, now I'm not going to waste my time factoring because, again, those directions said simplest radical form. So x equals negative b plus or minus the square root, parentheses, b squared minus 4 times a times c, divided by 2a, which you can do in your head. So again, I'm going to grab my calculator. I'm going to type what's underneath the radical. Do not type the radical itself inside there. And I get a 148 all over 14. Now it said simplest radical, so I have to break this radical down. So remember, you're looking for a perfect square and a non-perfect square. So I just start dividing my perfect squares until they work, if you don't know them off the top of your head. So I think 4 and 37 work. So x equals negative 6 plus or minus. Now which one of those do we know? The 4 is the number 2, radical 37, all over 14. Now remember, it's all about that GCF, so I'm going to pull out a 2 and say that's negative 3 plus or minus radical 37. Now notice, I am not touching the denominator, and most of us are really good at that. Don't touch the denominator. So the GCF is on top. Now I can say 2 goes into 2 once and into 14 7 times. So my final answer in simplest radical form, I would say there's 2 of them. Negative 3 plus radical 37 all over 7, and negative 3 minus radical 37 all over 7. Well, here we go with our third example. Solve the equation and express the roots in simplest a plus bi form. Well, we've seen nearest tenth, we've seen simplest radical, now they threw simplest a plus bi form. So what are they hinting? Well, as soon as you see an I, you should be saying, hey, I better get an imaginary number. Now, the only way to get an imaginary number, of course, is to have a negative under a square root. And what formula uses a square root? The quadratic formula, of course. So again, they're not coming out and saying how to solve it. You've got to know that all these words mean quadratic formula. So again, first thing I'm going to do is make this last term a fraction by putting it over 1, stating where anything can be undefined. Well, 5 can never be undefined. It is a defined number. It can only be undefined if it's a variable. So here, x cannot equal 0. So that's the only number I want to reject in case I get it. So I'm going to carefully rewrite these so we have common denominators. Now you'll notice I don't have any binomials. They're all monomials. This denominator is a number, and it's a 5. And this monomial denominator is an x. So I would say my least common denominator is a 5x. So I'm going to multiply this first fraction only by x, because it already has the 5. The second fraction only by 5. And this last guy needs both, so by 5 and x. Okay, looks like everybody has the same denominator, so we'll take our pencil and scratch it off. And we'll carefully solve that top equation. So I'm going to say that's x squared plus 8x, plus I'm going to distribute that 5x plus 25 equals 1 times 5 is 5, so I'm going to kill that, and 5 times x is 5x. Set it equal to 0, combine some like terms here, so let's see, that's x squared plus 13x plus 25. I'm going to subtract over the 5x, so it's set equal to 0. I'll keep chugging here. So I've got x squared, the 13 and 5 make a positive 8x plus 25 equals 0. Okay, so again, I'm not wasting my time thinking about factoring. I'm going straight to that quadratic. So I've got negative 8 plus or minus the square root, b squared minus 4 times a times c divided by 2a. Okay, so I'm grabbing my calculator, I'm typing everything but that radical in all at the same time, same line, don't do it in steps. And hopefully yours says the same thing. I've got a negative 36 on my end. Now, what's special about 36? Well, of course you know, it's a perfect square. So I can say this is negative 8 plus or minus. Now that's a 6, and that negative under the radical, you've probably got it jotted down already, that's an I, all over 2. Okay, so again, I'm going to pull out that GCF on top. 8 and 6 are both divisible by the number 2. So I'm left with negative 4 plus or minus 3i all over 2. And these 2's divide into each other, so I'm going to say I get two answers. I get negative 4 plus 3i, and I get negative 4 minus 3i. And there you have it. So we've covered 3 different types of equations tonight. One in simplest radical form, one in simplest a plus bi form, and one to the nearest tenth. So we've covered our irrational solutions as well as our complex. Well, we'll have some great practice tomorrow, and we look forward to working together. Have a great night.